its mysteries and marvels. From the secrets of black holes to the landscapes of alien worlds, we're here to ignite your imagination and expand your cosmic horizons. With mind-blowing visuals, expert insights, and the thrill of exploration, Spaceverse is your ticket to the ultimate cosmic journey. So strap in, hit that subscribe button, and let's embark on an epic voyage together into the vast unknown of Spaceverse. Explore the world of theoretical physics with Alice and Bob, two well-known explorers who are famed for their explorations. People who believe in the thought experiment, also known as the Gedanken experiment, whose purpose is to find flaws in our most fundamental theories in order to go deeper into the topic. On this courageous day, our daring pair will take a leap of faith and dive into a black hole. To get knowledge regarding quantum entanglement and the fundamental structure of spacetime, it is necessary to study. In both recent and older cases, it has been demonstrated that the notion of black holes can inspire odd ideas. That every piece of information about a specific volume of space may be contained within its borders is one example. Another example is the notion that there is a minimal meaningful distance in space. In addition, we made a fundamental observation regarding the manner in which that boundary can encompass an entirely new spatial dimension, which led to the conception of the electromagnetic universe. At that distance, on the other hand, we considered the possibility that gravity could be a consequence of thermodynamics. We had a conversation on the idea of embedding the emergent dimension in the scale of border patterns in 2 episodes that came before this show. Modern physicists working in this area, on the other hand, believe that quantum entanglement, which refers to the subtle correlations that exist between the bits of quantum information that describe the properties of particles, offers a more effective answer. To be more exact, as we will see in other episodes, it is beginning to appear as though entanglement is the very fabric of space. This means that space is knit together from the network of mutual information of its components. Alongside the evidence for the least Planck length and the holographic principle, the concept of entanglement's function emerged as a result of the consideration of black holes. In particular, while taking into consideration the fate of quantum data while it is contained within a black hole. When all is said and done, this will lead us to a significant connection between wormholes and entanglement in the ER=EPR hypothesis. Additionally, the same line of thinking will lead to black hole complementarity, which will completely mislead our intuition regarding the locations of quantum information. Black hole complementarity is a very interesting concept. On the other hand, the contradiction that lies at the heart of everything is something that we intend to establish today. The only way for it to occur is if Alice and Bob are willing to take the plunge into the abyss. To be more precise, it is only Alice. Over the course of her life, she has always been a little more bold than Bob. Therefore, Alice and Bob travel to the supermassive black hole that is located in the Milky Way, which is designated as Sagittarius A star. Alice puts on her jumpsuit as she gets ready to attempt the leap. Bob puts himself in a position to maintain his distance and observe. Alice is wearing a clock that emits regular pulses of high-energy gamma rays so that Bob may track her whereabouts and observe how the passage of time affects her. Bob is able to do this because Alice wears the clock. Alice also possesses a container that contains one electron with its spin locked. This electron is contained within the container. This is where our qubit, also known as a quantum bit, is located. In this case, the information belongs to the orientation of the spin of that electron, namely to whether it is oriented upwards or downwards. An further feature of the box is that it may be independently tracked by generating gamma-ray pulses at regular intervals. Her excitement at being the first person to glimpse beyond an event horizon causes Alice to give Bob a high five before diving headfirst towards Sag A star. She then throws the qubit box to fall slightly ahead of her as she begins to plummet. The first thing we'll do is examine it from Bob's point of view. Through the use of his gamma-ray telescope, he determines the passage of time while simultaneously monitoring Alice and the box's descent. Through the process of gravitational time dilation, the gamma-ray photons undergo gravitational redshifting, which causes them to stretch to longer wavelengths. Additionally, they arrive with increasing separation. At this point, Alice's light is nearly identical to, if not identical to, the black hole's Hawking radiation. The non-zero temperature of a black hole causes it to emit a faint glow known as Hawking radiation. Hawking photons with wavelengths exceeding 100 million kilometers are produced when the temperature for Sag A star exceeds 10 to the power of -14 Kelvin. Bob is doing his best to keep the experimental qubit under constant supervision. However, gathering all of the Hawking radiation that the black hole will release in the future is the sole option. He starts building a Dyson sphere-style detector to encircle the black hole in its entirety. In addition, he prepares himself for the long haul by uploading his thoughts to the ship's computer in the hopes of surviving this black hole. Let's take a look at Alice's experience from her perspective in the meantime. The descent into Sag-A happens over the course of a few hours, although by that time, it is typically well beyond the event horizon. As a result of her rapid acceleration, the final leg of the journey passes by at a rate that is exponentially faster than before. Regrettably, neither the acceleration nor the tidal forces exerted by the black hole contribute to the G-force. As Alice falls into an event horizon that is substantially larger than her, she has the sense of feeling as though she is not carrying any weight.